Hi, I'm Adolph Oliver, and today we're going to look at word problems that involve comparisons between two things. This is a very common thing that you run into, and there's an easy way to handle it. For instance, when two things are compared in one sentence, like we see right here, Jill is 3 years older than Sue. The easiest thing to do is to make the one on the end your variable, let's say x, and then, since Jill is 3 years older, it's going to be x plus 3. Now, if they said Jill was 3 years younger, you'd make it x minus 3. But this is the idea and how comparisons like this work, and once you pick this technique up, these types of problems are easy to do. So let's look at how the whole problem might exist down here. Here it is. Jill is 3 years older than Sue. Together their ages total 49 years. Well, remember, you set up here that Sue, the one at the end of the sentence, equaled x, and Jill, the one at the beginning then, was 3 years older, so x plus 3. Now, simply, our problem says the sum of their ages is 49. In other words, together their ages total 49. So simply just take these two and add them together. Here we go, equals 49. Well, remember, I like to keep the things that we're substituting here in parents so you can easily identify this is the x and the x plus 3. And of course, since we're adding these, there's a plus in front of the second set of parents, and since you don't see anything in front of the first set, we assume that to be plus also. And pluses in front of parents, as we well know, don't cause any changes. So everybody's going to say exactly like they are here. Let's just combine them together. This x plus another x is 2x plus 3 equals 49. Now, as we've said many, many times, remember what your goal is. You're aiming here to come up with x equals whatever number the answer happens to be. And this always reminds you who you want to keep on each side. We only want x terms on the left, so the 2x is good up here. We only want plain numbers on the right, so the 49 is good. The guy that's out of place here is the plus 3. We don't want to have any numbers on the left, so this tells us what to move. And remember, of course, when we jump them across to the other side of the equal sign, that changes its sign. So, when I move the plus 3 over as negative 3, I end up with 2x equals 48. Now, 46 I should say. 2x equals 46. And now divide both sides by 2, and we get x equals 23. Well, let's check and see if this works out. It's easy to make little goofs like I started to do right there. The 49 minus 3 is indeed 46. So you always double check your problems to see if they work at the tail end here. So we think x is 23. That means Sue would be the 23 years in age. Jill is the x 23 plus 3. That means 26. Okay, well, notice what the problem said, and you always check the problem, your final answer, against the words. Jill is indeed 3 years older than Sue, and if we add their ages up, they do indeed equal 49, so we know we're correct. Remember, in word problems, always check the final answer against the words in the word problem, not against your equation. You could have gotten the wrong equation, but if the answers work in the word problems, then you know that you're correct. Okay, let's look a little further on here. Here's another one of these. It says a wife is 11 years younger than her husband. Together their ages total 107 years. Well, again, make the one at the end of the sentence the x. The wife is 11 years younger, so she's going to be x minus 11. Okay, that tells us how to set this up. Now, together their ages total 107 years, so what we're just simply going to do is add these together. Okay, the wife is x minus 11. We're going to add to that the husband, which is x, and that has to equal a total of 107 years. Okay, officially again, we've got a plus in front of this first set of parents. So we turn around now, and there's no changes occurring with those plus signs, so we have a total of 2x minus 11. equals 107. Okay, well, remember, we only want variables on the left, numbers on the right, so this minus 11 has to move. It goes over as plus 11, so I end up now with 2x equals 118. Okay, well, the last step here, divide both sides by 2, okay, and we come up with x equals, what do we have here? I think it's 59. Okay, now, let's go back and check that against the words up here. We said then that the husband's age was X, so that means that his age is 59. The wife's age was 59, the X value minus 11, so 59 minus 11, we get her to be 48. Okay, well, let's check and see if these two things fit the words. First, is the wife 11 years younger than the husband? Well, 11 years younger than 59 is 48. And together their ages, if we add them up, 48 plus 59, let's add those and see what we get. 17, 10, 9, and 1 is 10. Yep, we get 107. There we are. Okay, so again, the comparison method allows us to set these up very well. Okay, here's another example. This one says Sue watches 5 hours more TV per week than Cindy. If they watch a total of 29 hours of TV, how much does each watch? Okay, well, we turn around and make Cindy equal to the X. She's at the end of the sentence. Sue watches 5 more, so Sue's going to be X plus 5. Okay, if we wanted to, we could write these up in a separate list here. Cindy then equals the X. Sue then equals our X plus 5. Okay, and why did we get that again? Well, remember, we made the person at the end of the sentence where those two people were mentioned. The one at the end, make your variable, let's say X, and then the other person in front, X plus 5 hours, X plus 5, because she watches 5 hours more. Okay, well, the total here is 29. So again, X plus 5 has to equal the total of 29 hours. Now, officially, we've got a plus in front of the first set of parens. Nobody's changing, so we got 2x plus 5 equals 29. Move the plus 5 over. Remember, we don't want any numbers on the left. And I get 2x equals 24. Okay, divide both sides by 2 on this. Okay, and we end up, of course, with x equals 12. Okay, use that now to figure out what the individuals were. Remember, of course, they wanted to know how much each watched, Cindy and Sue, so x is 12. Sue is 12 plus 5, which is 17. Now check this against the words very carefully. Okay, Sue watches 5 hours more TV than Cindy. Well, Sue is definitely 5 more. And together, let's see, we've got 9 and 2, together 29 hours. So again, check it against the words. It does work. Okay, now of course we're going to run into some geometric things as well. Here's one that says the perimeter of a rectangle is 54 inches. The width is 3 less than the length. Well, here's a sentence where two things are mentioned in one sentence. Make the one at the end again your x. That's length. The width is 3 less, so we'll make the width then x minus 3. So again, in these comparisons, we're comparing two things, width and length. Make the one at the end of the sentence your variable. The other one's easy since it's 3 less. That means x minus 3. Okay, so in a problem like this, when you have a geometric figure, it's often easier to just make a sketch, a generic rectangle. Here it is. And so we've got the length, which is x, so here are the two lengths. And we've got the width, which is x minus 3, so here are the two widths. The width's the shorter side, the length's the longer. And it says the perimeter is 54 inches. Well, you want to remember perimeter means added up all the way around. So if we just took this particular figure that we've sketched here and went around and added up all of the sides, let's say I started with the bottom here and then went around this way, I'd have this first x, then I'd have another x minus 3, I should say, put that minus in there, plus another x, and then plus the last side plus x minus 3, and that has to equal the entire perimeter, which they said was the 54 inches up here. Okay, so officially we have a plus in front of this first set of parens. Since everybody has a plus in front, nobody is changing here, so we can collect all these terms. There are a total of 1, 2, 3, 4 x's. Okay, and of course remember this was a minus 3 here, and this is another minus 3, so minus 6 equals 54. Now, as usual, what we have to do is anybody that's on the wrong side, move them. The 6 is a plain number. We only want variables on the left, so the negative 6 has to be moved. We jump him over as positive 6, and I end up with 4x equals 60. Divide both sides by 4, and we get x equals 15. Now, that's going to allow us to go back and get what our sides are. Where can you put this information? Well, one thing you can do is just label it right up here on that generic rectangle that we made. For instance, the length here is 15. Remember, our x is 15, so this is just 15 inches. And the width here is going to be the x value minus 3, so 15 minus 3 equals 12 inches. Now, be sure that you put the units on these. Word problems that have units like this, it's important to do that. Now, here it is. We'd have two of these 15s, which would be 30, and two of the 12s, which would be 24. 30 plus 24 does indeed equal the 54 inches that this problem required, so we can tell that we're correct. Okay, well, geometry problems like that are common, but we can also have everyday types of things. For instance, Sue spends 2/3 as much on clothes as Lucy. Together they spend $260. How much does each spend? Well, again, when you have two things mentioned in one sentence like we do here, make the one at the end your variable. That would be Lucy. Sue spends 2/3 as much. Well, that's going to be then 2/3 times x. So we've got both of these set. Now we can go ahead and label those. So we made Lucy, okay, equal to the x, and Sue equal to the 2/3 x. Okay, now, together they spend $260. Well, that means we've got to add these guys together. Here's how much Lucy spends, plus how much Sue spends, 2/3 of an x, okay, equals the $260. Officially a plus in front of the first set of parens. And now, there's collect the like terms is what we do first here. I've got 1x here and 2/3 of an x, so you could write this as a mixed number. 1 and 2/3 x equals 260. But in the algebra, for solving things, it's much easier if you take a mixed number like this and convert it to an improper fraction. So 1 times 3 is 3, plus 2 is 5. This is 5/3 x equals 260. Now, the reason you want to do that is anytime you have a fraction times your variable, the easiest way to get this back to just a single x, remember, we want to know what 1x equals, is multiply both sides by the reciprocal of that fraction. So here we go. Multiply both sides by 3/5. Well, on the left, the 3's cross cancel, the 5's cross cancel. We end up with just 1x, or x equals. Now over here, make a fraction out of the 260 by putting a 1 underneath it. And let's turn around now and reduce this. 5 does go into 260. 5 goes once, it goes 5 times in the 26. That leaves me a 1, and the next 0 makes 10, so it's a total of 52 times it goes. Okay, what's x in? 3 times 52, which would be 156. Okay, let's go back and see if this indeed works with what we have. Remember, we've got the x equal to 156, so if we go back to the top up here, that means Lucy spends $156. Sue spends 2/3 as much of that. Let's off to the side here. We've got a little bit of room. Figure out what 2/3 times 156 is. And we could do some cross canceling here. This goes in 52 times. 2 times 52 equals 104. So that means our 2/3 of x, 2/3 times 156, means that Sue spends 104. Okay, well, we know then that this 104 is 2/3 of 156. We just did it here. And what does it get when we add these up? Yes, indeed, it does end up giving us the 260, which was the total amount that the problem said that they spent together. Okay, let's go back to another geometric type of problem, this time a rectangle. It says here the perimeter of a triangle, to a triangle here. The perimeter of a triangle is 15 inches. The second side is 4 times the first. The third side is 1 more than twice the first. Find the 3 sides. Well, again, here's one thing you can do with this. You can make yourself a generic triangle. Here we go. Just sketch one in and label it. Now, we know the perimeter is 15 inches. We'll use that in a moment. But first, we got to figure out things for the sides. The second side is 4 times the first. So let's make the first one x, and then the second side is 4 times that, so the second side will be 4x. Okay, so x and 4x. Now, where do you label those? Well, remember, we're not worried about the sides representing the values. We're just doing this kind of generically here. So let's say this is my first side right here. The first side we made x. The second side, if this is it here, is 4x. Now they've got to tell us something about the third side coming up. Here it is. The third side is 1 inch more than twice the first. Okay, well remember, we made the first guy x from the first sentence up here, so he's still x. The third side then is 1 inch more than twice the first. Well, how are we going to take twice the first? That's going to be 2x. And then 1 inch more plus 1. So that means that third side then is going to be twice the first side plus 1 more inch. And since the first side here is x, we get 2x plus 1. Okay, well, what we've done basically is use the comparison twice. The first sentence told us between the second side and the first. The second sentence said between the third side and the first. And we just build up our values in x based on that. Now, of course, remember they told us the perimeter is 15 inches. Let's make use of that. Perimeter means, of course, we've got to add all the sides up. So if I start with x here, I've got to add the next side, which is 4x. And then I've got to add the third side here, which is 2x plus 1. And that, of course, has to equal the total of 15. Okay. Well, officially there's a plus in front of this first set of parens, since we didn't see anything there. And everybody's got a plus in front, so nobody's changing. So we can turn around now and combine everything together. I've got 1x here plus 4 more, that's 5, plus 2 more. That's a total of 7x. And the only number I have is a plus 1, equals 15. Okay, well, as usual, we look for who's on the wrong side. Variables are okay on the left, numbers are okay on the right. The one guy that's on the wrong side is this guy, so we move him over. Plus 1 becomes negative 1, and we got 7x equals 14. Okay, divide both sides by 7. We get x equal to 2. So x equals 2. That we're going to use now to go back and come up with what all these sides are. That means this first side was just 2, and remember now, this is in inches, so there it is. You better put the units down. The next side here is 4 times 2, which then gives 8 inches. Okay, there's that side. The last side here is 2 times 2, 2 times 2, which is 4, plus 1. That means the last side here is 5 inches. Okay, let's check this one against all of the word information we have now to make sure that it's correct. First off, do these add up to 15 inches? Well, 2 and 8 is 10, plus 5 is 15, so we've got the right perimeter. The second side is 4 times the first. Well, this side here is indeed 4 times that. And the third side is 1 inch more than twice the first. Well, twice the first would be 4, plus 1 more inch would be 5. There it is. So again, our comparison method, make the guy at the end of the sentence your variable x, allows us to build these up very easily. Okay, here's another example here. A 10-foot rope is cut into 3 pieces. The second is 1 foot less than twice the first. The third is 1 foot more than twice the first. What are the lengths? Well, we've got 3 pieces here, so let's make ourselves a list. First piece equals, second piece equals, and third piece equals. Okay, now let's go back and do the comparisons. The second is 1 foot less than twice the first. So if I make the first one x, the second is 1 foot less than twice the first. Well, twice the first would be 2x, but then 1 foot less means I've got to subtract 1. So again, we're doing our comparison work here. The one mentioned at the end of the sentence, we make our x, that's the first piece. So that is, first piece is x. The second piece is going to be twice that and 1 foot less. So 2 times x would be twice, but minus 1. There's the second piece. Okay, the third is 1 foot more than twice the first. Well, remember, of course, we've got the first equal to x. So the third then is 1 foot more than twice that. So this third guy then, we'd have to have twice the first, but then 1 foot more, so plus 1. So he's going to be 2x plus 1. Okay, well, that's how we build up the expressions here that we're going to use to solve this. Now remember, they told us this was a 10-foot piece of rope, so that means all of these pieces have to add up to 10 feet. So let's start adding them together here. Okay, here's the second piece. Here comes the third piece. And that total equals 10. Okay, well, remember again, here's the first guy, here's the second, here's the third. That's why I like to put them in parents, so it highlights them. Officially, there's a plus in front of the first guy, and since they're plus in front of the parents, nobody's changing. So we can go ahead and combine the like terms exactly the way we see it here. I've got a single x here, 2 more makes a total of 3, 2 more makes a total of 5, so I got 5x. Now, for the numbers, I've got minus 1 and plus 1, and they zero out, so there's no number left on the left side. We just get 5x equal to 10, and of course, it's real easy to see if we divide both sides by 2 here, that we end up with x equals, divide both sides by 5, I should say, we end up with x equals 2. So the 5's cancel here. We get x. 10 divided by 5 gives me 2 here. So let's see if this is correct here. Okay, here we go. X, if it's just 2, means this is 2, and it's in feet. This one's going to be 2 times 2, which is 4, minus 1, which is going to give me 3 feet. And this third piece is going to be 2 times 2, which is 4, plus 1, which gives me 5 feet. Okay, now, first off, what's the total length? Well, 2 and 3 is 5, plus 5 more is 10, so we've got the 10-foot length of the rope correct. Remember, the rope had to be 10 feet up here. Now, let's check out the relations. The second is 1 foot less than twice the first. Well, if we take twice the first, that would be 4 feet. 1 foot less is 3. That looks good. The third is 1 foot more than twice the first. Well, twice the first is 4, and 1 foot more equals 5. So again, checking it against the words, we can tell that we're correct the whole way. Okay, well, let's visit one last example here, and triangle again. But now we're not going to be talking about the sides, we're going to talk about the angles of a triangle. Now, one of the things you have to remember from geometry, okay, is that the sum of the angles of a triangle equals 180 degrees. Okay, this is something that you have to know, just like a triangular formula for area or formulas for area for other geometric figures. The sum of the angles equals 180. Okay, well, one of the things we can do is just make ourselves a list. We've got first angle, and that little symbol right there is what mathematicians often use for angle. Looks like the corner of a triangle, so it's like a single angle. So first angle equals, second angle equals, and third angle equals. Okay, let's go back now and do the comparisons on this. The second angle of a triangle is 3 times the first. So the guy at the end again, make your variable. The second angle is 3 times that. Well, that's 3x. The third angle is, well, let's just put those down first. First angle is x, we got that. And the second angle is 3x. Now, let's see what they say about the next one. The third angle is 5 degrees more than the second. Well, the second angle we've already made 3x. So we take that value that we've already set for the second angle. So if it's 3x and the third is 5 degrees more, the third is going to have to be then 3x plus 5. Okay, so again, we've used all of our comparison information here. The third angle is 5 degrees more than the second. Notice we already made the second 3x, so the second is 3x. 5 degrees more would be 3x plus 5. There's our third angle. Okay, now you have to make use of that bit of information we said that you should know about triangles. The sum of the angles in any triangle, add all 3 of them up, they always equal to 180 degrees. So that means add these guys up, which is what we do next. Here we've got x plus the 3x plus the 3x plus 5. There are all 3 of the angles, the x, the 3x plus 5, and that has to equal 180 degrees. Well, officially again, there's a plus in front of this first set of parens. So now what we do is realize that the pluses mean there's no change in sign. So I've got a single x, 3 more, that makes 4x, 3 more than that makes 7x. So I've got a total of 7x plus 5 equals 180. Okay, now solve this equation. The one guy that's on the wrong side is the plus 5. He has to go over as negative 5. So we get 7x equals, what do we have here? 175. Okay, divide both sides by 7. Let's see what we get. Here it is. The 7's cancel out. So we're going to end up with x equals, well, 7 goes into 17 twice. That's 14. That leaves a 3 and a 5, which makes 35, and 7 goes into 35 5 times. So this guy here reduces to 25. Okay, well, now we use the x equals 25 to get all of our angles up here. Let's do it. Okay, that means the first guy here is 25 degrees. The second guy is going to be 3 times 25, which means he's 75 degrees. And the last guy is going to be 3 times 25. That's 75 plus 5. That makes him 80 degrees. Okay, well, let's add this up. 25 plus 75 is 100, plus 80 is 180. We see that we do match the 180 degrees total. Now let's just check against the rest of the words here that everything is correct. The second angle is 3 times the first. Well, 3 times 25 is 75. That's correct. And the third angle is 5 degrees more than the second. Well, the second is 75. 5 more degrees is 80. So, yes, indeed, this works against all the words. So we know that we're correct.